So, in this lesson, we're going to talk about density, mainly because one of the ways that we measure osteoporosis and bone fractures is through density. So, let's take a quick refresher on what density is. So, the formal definition of density that you need to know is how much matter is given in an amount of space or volume. So, essentially, it describes how hard or how soft an object it is, right? So something with a high density is like a stiffer or harder object. You don't want to punch through that, right? Something with a softer density is more like a pillow. So if I could zoom in to the particles or the pieces of matter that make up each object, this green fuzzy ball has a low density because there's less matter or particles in this amount of space. However, this green Lego block has a high density because it has more matter or particles within this space, right? So high density just means there's more stuff or more atoms or more particles in the same amounts of area. How do we calculate density? Well, the equation for density is just mass divided by how much space it takes up or volume, right? So know that these symbols for density, D is for density, M is for mass, V is for volume. And oftentimes you'll see them in these units, but they might be a little bit different, right? So here's how you calculate density. First, if we know that density is just mass divided by volume, then when you're doing a lab, you just need to collect these two things, right? Once you figure out what the mass and the volume is, you can plug it into the equation to find density. So let's say you want to find the density of this piece of bone. The first thing you need to do is find the mass of the object on the scale. So the density of this bone, the mass of this bone is 19.00 grams. Then you need to find the volume. And in the previous lessons, we talked about two ways to find volume. One is through geometry, length times width times heights. The other is through water displacement. So because this bone is irregular shaped, you'd probably want to use water displacement. So here, the starting volume without the bone is 10 milliliters. After you drop in the bone is 20 milliliters, right? So I need to subtract these two numbers, 10 and 20, in order to find the volume. So when I'm doing it mathematically, I know that my mass is 19 grams. My volume is 20. From here, the final volume, minus 10 will give me 10 milliliters. So therefore, density is 19 divided by 10, which gives me 1.9 grams per milliliter. So you might ask, why did I divide? Because the equation is mass divided by volume. Okay, so what can I do with density? So for non-medical related things, you can tell if something is real or fake if you know its density. And the reason being is that density does not change no matter what size the object it is, as long as it's made of the same stuff. So if you have a tiny piece of gold or a gigantic piece of gold, the density will still always be 19.3, right? Here I have a picture to show you mathematically why density doesn't change depending on the size. So if I look at one box of a particle or a thing that has a density of 5, all right, let's say its mass is 5 because it has 5 of these mass or matter pieces, and then one box represents the volume. All right, so 5 divided by 1 is 5, so that's the density. But if I make this object that's made of the same stuff twice as large, like on this side, now my mass is going to be 2 times as much, right? So now I have 10 pieces of matter, but the volume is also bigger. So my volume is also twice as much, right? So if I take 10 divided by 2 again, I would still get the same density, 5. So the key thing here is density does not change depending on the amount of stuff you have. Density is always the same as long as it's made of the same stuff. And that's why you can tell whether something is real or fake. So for example, if I asked you, what is this shiny metal made out of, right? What is its density? Because density doesn't change depending on the size, you can figure out the density of this and then match it with what this is. So go ahead and take a moment and pause. And knowing that the mass of the necklace is this much and the volume of the necklace is this much, what is this object probably made out of? Okay, let's go over this. So I know that the mass is 241.5 grams and the volume is 23 milliliters. And using our density equation, mass divided by volume, my mass is 241.5 divided by 23 milliliters, that's my volume, will give me 10.5. So I know that the necklace has a density of 10.5. And looking here, what has a density of 10.5? Well, silver. So this necklace is probably made of silver. You can also tell if something will sink or float in general. So if water has a density of 1 gram per milliliter, will any of these objects float? Well, no, because all of these densities are greater than 1. If it has a density of less than 1, then it will float. This is ignoring something called buoyancy right now that you'll learn in physics, right? So if you know about buoyancy, you'll probably know that technically these can float if I do something else to it. It depends on the shape, right? But in general, if we're just looking at the density of an object, none of these will float because they all have a density of greater than 1 gram per milliliter. Right. Finally, you can tell whether someone has osteoporosis or weak bones if you know their density. So that's the next lesson, and you can click on to lesson 1.5 now to complete that.